Okay, we're going to continue our quadrilateral doodle notes. We're going to do rectangles, rhombuses, and squares today. That's going to be on slide 2. So I'm going to click on slide 2, and I'm going to zoom in. Can't see the zoom in button there, but it looks just like what you see on my screen. And I'm going to zoom in a little bit. I think if I go one more, I think it'll be a little too much. Maybe not. That might work. We'll see. Okay, so here I've zoomed in on the rectangle box. Feel free to zoom in as well. And we're going to talk about the rectangle. A rectangle is a parallelogram. Okay, so parallelogram. And it has all right angles. Right angles. Okay, that's what makes the definition of a parallelogram. A rectangle. It is a parallelogram, so everything that we filled out on page 1 for parallelograms apply to the rectangle, since the rectangle is also a parallelogram. Okay, so we still do need to draw in our diagonals and all of our properties here. So since it is a parallelogram, the parallelogram states that both pair of opposite sides are parallel. So I'm going to indicate that with the parallel line marks. So there's that set of parallel lines, and we have a second set of parallel lines. Okay. We also have all right angles. Okay, so we're kind of used to seeing that as a square in the corner. Most of the time they're red, so they stand out. So there's the all right angles. Okay, so not only are these sides parallel, they are also congruent. So I have these green marks mean that those two sides are equal to each other, and this mark on the left and the right mean they are congruent as well. Okay, so opposite sides are parallel and congruent, and that's really coming from the property of the parallelogram. They are parallel and congruent, meaning they are equal. And you can move it up to fill in the line. Diagonals bisect each other. Diagonals bisect each other. So that's another property that is the same from the parallelograms. But they also work in the rectangle as well. So if I draw in my parallelogram, draw in my diagonal, use a different color here, pink. And I go from one end to the other. There's a second diagonal. They split each other in half. So this piece would equal this piece, and this piece would equal this piece. They bisect each other. Okay, if I move it down a little bit, and it's going to throw off my drawing, so make sure you have the drawing or pause it at the moment, because I do have to go down to fill in another blank. Diagonals bisect each other and are congruent. So we're going to fill in our box for congruent. And again, we can move that text box to fit on the line. Okay, so that is our rectangle. I'll move it up just a little bit to get my drawing back on. So a rectangle is a parallelogram. It has all right angles. The opposite sides are parallel and congruent. So those are the blue marks and the green marks. The diagonals bisect each other, so they split each other in half, and that makes them congruent. So that's the dark red marks. Okay, so I'm going to scroll down to the rhombus. The rhombus. This see if I can scroll up just a little bit so I make sure I get everything in there. Okay, so a rhombus is a parallelogram and this time it has all congruent sides. It has all congruent sides. Congruent sides. Okay, so I'm going to move that one better on the line. All congruent sides. All right. So what that means on the drawing is that every side is the same. Okay, so this top side is the same length as the right side, as the bottom, as the left. They're all the same. It is a parallelogram, which means that the top and bottom are parallel, and the left and right are parallel. Okay. So coming back, we have opposite angles. Those are going to be congruent. Opposite angles, those are going to be congruent. So when I mark those on my diagram, so that acute angle is going to be congruent to that acute angle. And this obtuse angle is going to be congruent to this obtuse angle. Opposite sides are parallel and congruent. Again, that's consistent with the parallelogram property. Opposite sides are parallel and congruent, and we marked that already. That's the blue and the green markings. Diagonals bisect each other. Okay, so that's still a parallelogram property that transfers over to the rhombus. Okay, so if I draw that in there, we use the dark red one. So diagonals bisect each other. If I connect the points that make diagonals, so this piece equals this piece, and this piece equals this piece. They bisect each other, they split each other in half, and they also are perpendicular to each other. Since we used red for the 90-degree angle symbol, they are perpendicular to each other. So when we come in here, that's where perpendicular goes. They are perpendicular to each other. Okay, another property that translates from the parallelogram to the rhombus is the consecutive angles are supplementary. Supplementary. They are supplementary. That means they add up to 180. Ooh, got off on my drawing. There we go. Okay, so that means that a single orange and a double orange add up to 180. Double orange and single orange add up to 180. Double and single add up to 180, and the double and the single add up to 180. Okay, so those are supplementary. And again, that's a property of the parallelogram that transfers over to the rhombus. That also applies to the rectangle too, because all of the angles are 90. They're also going to be supplementary next to each other as well. Okay, now we're going to move to the square. Get it all on that one zoomed in page. Okay, so now we have a square. And a square is a parallelogram. And it has all four sides. All four sides. Those are congruent. And it has all right angles. Put all of that on one. Okay, it has all right angles. So this one combines both the rectangle and the rhombus. It combines the rectangle and the rhombus. The rectangle is the fact that it has all four right angles. And the rhombus part is that all four sides are congruent. Okay. Opposite sides are parallel. It inherited that from the parallelogram. And all sides are congruent. They're equal. So that takes on the property of the rhombus. Since all sides are congruent. And the diagonals bisect each other. That's coming from the parallelogram. That applies to everybody involved. And they are both congruent and perpendicular. Congruent and perpendicular. And that comes back to kind of both of them, the rhombus piece. Okay, so if I mark my diagram, it is a parallelogram. So those markings go. These two are parallel, top and bottom. Left and right are parallel. Then we have congruency. All four sides are the same length, so they get the same congruency mark. The diagonals bisect each other, so when I crisscross my diagonals, and they are perpendicular. So they are perpendicular there. We've got to mark that they are congruent. So actually in this one, they are actually the same measurement because of the length. So all four pieces are equal to each other. And these are our properties. Okay, so we have the rectangle, the rhombus, and the square. They are all parallelograms. What makes the rectangle unique is the fact that it just has four right angles. What makes the rhombus unique is the fact that it has four equal sides. What makes the square unique is a combination of both the rectangle and the rhombus. And they are all parallelograms. Okay, stay tuned for part 2 when we go over some of the exercises.